We'll be talking about various attacks on CAPTCHAs that will focus on CAPTCHA schemes and implementations. So I'm Gursev. I work with Fonson McAfee as a managing consultant. I have written one tool for SSR enumeration as a smart that is available as an open source. Then this is the second one, and it's for solving CAPTCHAs, and we'll be discussing that and demoing it towards the end of the presentation. I do security research, work on web applications, network assessments, mobile applications, and more. Work on Ruby, C#, Rails. If I need to do something quick, it's Ruby. If I need to do something more elaborate, shift it to C# after my experiences with the GUI in Ruby. So let's go ahead and look at how all this was done, which I'm going to discuss today. So I looked at Quantcast's top 1 million websites. I mean, not all 1 million, but 200 plus CAPTCHA schemes from top Quantcast, top million websites were chosen based on how the CAPTCHAs were created, the images were generated. And then scores of websites were analyzed for how the CAPTCHAs are implemented. The implementation part looked at register pages, forward password pages, contact us and feedback pages. So these are the pages which normally have CAPTCHA protection built into them. And this was a good point to look at how the CAPTCHAs are being verified at the back end, how the solutions are getting stored and whatnot. And the final part, CAPTCHA schemes. Then I used a couple of OCR engines which can be used to extract text from images. Then I had to write custom image pre-processing libraries right from scratch to ensure that they do just what I want them to do and they are not very heavy. So CAPTCHAs are more than just the image. So there's a complete life cycle right from the time you make a request to a web page. For example, you go to register.php. Is that visible from here? Is that visible? Because I just want to ensure this is visible from the back rows. So the first request goes to the register page. As I said, one of my scope was to look at the register pages, and this is why I'm taking you through this is because I'll be referring to this slide a couple of times in the presentation, and this will give you an overview of how CAPTCHAs are really born and how they die towards the end of the cycle. And it's important to understand this before we get deeper into the various attacks that we're going to discuss. Then the application generates session ID for the correct registration request. This is one very critical component. Even though CAPTCHAs are pre-op, but they have to be living on sessions. If they do not, they will be bypassed, and they will be bypassed at all the cost. I mean, there is no point sparing them if the session is not being used at the server side for CAPTCHA implementation. Then the page comes back, it says HTML and the image source and of course the HTML page here. The next request goes to the server, which requests for a CAPTCHA, and it sends the session ID. So we can see that the request to the CAPTCHA URL is not the first one. It is always after the register page or after the user obtains a valid session ID, if the session ID is being implemented. And then the website generates a random CAPTCHA, stores the CAPTCHA solution in the HTTP session, returns the CAPTCHA back to the user. A post comes with all the form fields and the CAPTCHA solution. The solution is verified at the server, and then depending on how the things are, if the solution was correct and the form fields adhere to how they are supposed to be, you go to the success page or you go back to the first page, which is register.php, the first page. So,
is the session ID required to generate the random CAPTCHA, or is it just for the security measures?
That's only for security. We're not supposed to have this. So, from security point, yes, we should have that, but otherwise, it's not a mandatory thing. But you will realize towards the end of session how important this is. So from here on, we will be looking at the attacks that we are going to have on CAPTCHAs. It will be looking at the client-side trust, the simplest things and the most foolish things that I saw during my research over like 200 websites. Then server-side attacks, how the server, session, and CAPTCHA IDs implementations were a bit flawed, and how they can allow an attacker to do a number of successful requests without really needing to put in a lot of work. Then we would look at TesorCAP, the tool which I developed to solve CAPTCHA schemes. So if everything is well on client side, everything is good on server side, then there is the image that has to be secure. And if that is broken, the CAPTCHA is still not secure. So this is a tool that will help you analyze your CAPTCHAs. And then we'll try to play an exercise towards the end of the presentation. So breaching the client-side trust. Hidden fields, client-side storage, and more. I may not say more than this, but I'll still show you some of the images that I captured for this presentation. I strongly believe that an image is more than 1,000 words, and I have relied heavily on graphics. I mean, not extreme graphics, but graphics throughout the presentation. So if you're not able to see anything because of size, the presentation would be available to you in the PDF or whatever format these guys choose to provide you, and you can go through that. So here you see the website uses CAPTCHA. The CAPTCHA solution itself is part of the response. So what I need to do is just load the page and parse the HTML and then send that back to the server for verification. Sometimes, again, as I said, if there is no session being maintained for a particular registration request, the server would not know what is the CAPTCHA that it sent over, and you can pass on your custom solution. So here, this is a request for the same website, and it's going to the sign up page with the solution that was provided by the server. I changed that, and then you have the solution that came from the user. This is the entered one. This is what the server sent back. So this is what the server sent, and this is what I sent to the server. Since it did not maintain any session information, there was nothing for it to verify because I can script it out very easily. I don't even need a session ID. I can just have a script, provide two values for, one is for the parameter CAPTCHA, second is CAPTCHA user, and then do thousands of account creations and whatnot. This is one very interesting implementation. I believe this won't be visible from the back, but just to elaborate, the code here which you see in green, this was a client-side CAPTCHA verification. So JavaScript was being used to verify the CAPTCHA, and the CAPTCHA value was not at all being sent to the server. I mean, no points for breaking this one. Let's go and see a few more. This was a particular implementation that was interesting because they were using JavaScript to generate a random number. So here we have this JavaScript. They had this random number generator function they were calling from here. And this was sent to the server to retrieve an image. And if you see the number here, it is 709878, and the same number is at the image. So basically, I load up a browser, I parse the DOM, I extract this value, and I send over to the server. So basically, there is no protection again. And this is one more of the similar class. Base 64 is not encryption, and this is what these guys thought was. This is not. This is some like housing website. I'm not sure which one was that. So this is. Now let's see this arithmetic CAPTCHAs. Many of you might have seen these CAPTCHAs, right? What is 5 plus 5? What is 8 plus 2? Surprisingly, these two numbers were also not random. So they were like centered around 5, 6, 7, and 4. These were occurring most of the times, and then even if you want to do just a brute force, it will take 20 attempts for one successful submission. Similar one, 20 attempts maximum. If you want to pass, lesser. Let's talk about server-side attacks. One very important thing which I saw was, if I go to a lot of websites, they really do not want to generate CAPTCHAs at runtime. What they would do is generate CAPTCHAs, a limited, maybe a large number of CAPTCHAs, have them in the database, index them with certain value, and they'll pick one of those and send over to you. So basically a lot of CAPTCHA use happening. So CAPTCHAs are generated at runtime. Limited number of CAPTCHAs. So when you have limited number of CAPTCHAs, they can be locally stored, enumerated, solved, and then later used against you. Then, as I said, static values. These are the values that are being used in sessions or being sent back to the client for verification purpose. I don't know why. This is one of the most popular implementations out there. a very high if you just go through Medium and start seeing the websites which have CAPTCHAs, you will be surprised at the number of websites who have indexes and start a limited number of CAPTCHAs.
How do you figure out that they are not doing it on time? I mean, you keep scrapping,
Yeah,
and you start seeing the pattern again and again very.
So 2 ways to do that. One, I get a session ID, right? So basically the request goes like this. You go to the get CAPTCHA.php page,
Yeah.
right? And they would send you a redirect with the CAPTCHA ID. Most of the time this happens, or the ID comes back as a hidden field. So if you request for that ID, image with that ID, it will be the same image that will come back again. A lot of times I saw that. And there were ways in which even if you don't get an identifier, you can still break that. We'll talk about that in a minute. So some websites use numeric identifiers like 0, 1, 2, 3. Basically you can see their maximum number is around 10,000. You can download all the 10,000 CAPTCHAs, solve them locally, and then when you're brute forcing them, you just need to know this is the CAPTCHA value. If this is the ID, I need to send this value. For example, if you get an ID of 3, you just look up in your table that for 3, what was there? It was 49F1C. So just send that back for the post request and it gets through.
You were able to see the numeric identifier when you're requesting for a CAPTCHA.
Yes, so that's what I said. For redirects, we'll see other examples in which I have detailed how these identifiers were seen and the other tags against this particular implementation when you have individual numeric identifiers or alphanumeric identifiers as in this slide. I saw this type of implementations as well. Of course, the CAPTCHAs which I have chosen one are not the exact ones which that website used, but this was a very serious thing which I saw. For example, the identifiers you're talking about, if I don't get to see identifiers, what do I do? In this case, so what I was doing was trying to get a lot of, say, thousands of images from the website, and I tried to calculate every 5 of those images and then try to compare. And surprisingly, because I cannot solve all of them, right, and then see the results, so I did hashes and saw that images were repeating time and again. That was a big eye opener because they wouldn't repeat if you have like 1,000 or maybe 5,000, but the moment you start crossing 10,000, 50,000 number, you really start getting CAPTCHAs which are coming back multiple times. So this was quite a good discovery. And then sometimes the identifiers change and the images, rather being static, they add random noises to the image. In those cases, well, one has to write custom software for these things. Let's talk about the chosen CAPTCHA identifier attack which you were discussing. So what happens is this, the request goes to the server which says get me the CAPTCHA and this is my session ID. So this session ID is what individual has before, he got from the register page, the very landing page, right? So it comes here, so the random CAPTCHA identifier is picked up, it is sent back to the user and the identifier is sent back in the hidden, as a hidden field so that it can come back for the server to verify which CAPTCHA it has to pick up for verification. Then the user submits its request with the identifier, and then the identifier is used to retrieve CAPTCHA solution and verify the solution. And again, the other steps like success and failure. So what this chosen CAPTCHA identifier attack means is, once you know a particular identifier, just one request would be good enough. You know this identifier, you solve it locally, manually or maybe using some CR engine. Then you use that identifier for all the requests that you are sending from here on. So the server has no way of knowing that this was the identifier that was assigned to you. So it will pick the identifier from your request, look into its database for the solution and compare against what you are providing. So you solve one CAPTCHA and then you have tons of successful requests going on.
So on the server side, there is no association between the session ID and the identifier itself.
Sometimes they do maintain, but most of the times, whenever they send identifiers, I saw that they are not relying on session at all. They just use this identifier to retrieve CAPTCHA from database or whatever their storage is. Not a good implementation, but that's what a workaround is when you don't want to do sessions pre-authentication. This was a little. The problem is the request that comes at 4 is again controlled by the user. So what I would do is, this attack is, I believe I'm rushing through it a bit fast, but if you have any questions, please feel free to stop me anytime. Or if you feel like you're going slow, please let me know. So here, the request code is coming from the user, right? So what an attacker can do is, he can just get a session ID, go to the register page, get a session ID. And he has to know one CAPTCHA identifier. So what he does after that is, using that session identifier, plus one CAPTCHA ID he knows earlier, he does this. He uses that session ID and that CAPTCHA ID. He makes a request for CAPTCHA. So what the server does is, it associates this evil ID into the HTTP session and then sends back the CAPTCHA. So basically to fix the CAPTCHA what you want to get, and that is what the server understands when you send your request back. Is this a bit clear or hazy or what? Postman?
Can you go to the previous slide?
Sure.
So, how random is your CAPTCHA ID? Is it sequential or is something random?
So in this scenario, it really does not matter. I just need to know one CAPTCHA ID. Sometimes
If I have to extract another CAPTCHA ID.
so some websites have it sequential. Some have very long keys, like 128, 130 character long keys. But the moment you make request to, so the ones which have like 130 character long keys, these websites, they basically respond to, they work in this way. So you would request a generic page that would in turn assign you an ID. And if you can run through this multiple times, or say thousands of times, you have thousands of IDs and CAPTCHAs with you. So basically that is the approach that I use during my research.
So when you register, you have to fill in the CAPTCHA, and sometimes the CAPTCHA is not visible, or you're not able to interpret it. So you do a refresh.
Right.
Right. So in that case, the session ID remains the same.
Right.
So then how does that make? Because the page isn't refreshed. It's just in the application.
So, I was not able to understand the question. I understand that you're saying that I have to refresh a CAPTCHA, right? So, what is it?
So what
Session
goes on at
ID
the
change
back
or
end?
it gets refreshed. The session
What
ID
goes on
is
at the back end? What happens?
So, this is one thing which is interesting about CAPTCHAs. There are no standard coding guidelines for CAPTCHAs available. So, people implement it in their own way. Everybody implements. Somebody wants to minimize CPU utilization by creating static CAPTCHAs. Somebody wants to say be okay with the CPU utilization, but they don't want to create static CAPTCHAs. They do it randomly. So this is one area where there is no standard guidelines other than few CAPTCHA providers like reCAPTCHA, who basically allow expose API or web services which you can use to verify. So they are still okay. In this scenario, reCAPTCHA is the one that verifies it. The web server doesn't verify that.
So then how does it happen? Like since you
For the reCAPTCHA, so this attack doesn't work against reCAPTCHA. As I said,
Does this happen?
yeah. So this is one of the scenarios that I found and were exploitable. I worked with around 200 to 300 websites for CAPTCHA schemes and these implementations. So this was again observed in around 5 or 6 of those. So quite a good deal. And I would say it's around 2% of the websites on which I worked. So this evil ID then goes into the session, and I have one ID. If the IDs do not change over time, I can use one ID and keep on creating requests whenever I want. Right? Then CAPTCHA accumulation. This was very weird. So this I found in one website, but I just wanted to share for that's the fun of it, because every time you make a request, this website would create a new CAPTCHA and store them solution, and they would add all the CAPTCHA solutions one by one. So it allows a few CAPTCHA solutions to be used for several submissions. For example, I make one failed request, that solution goes into the HTTP session. I make another failed request, that session also gets appended to that rather than replacing that. I had no clue how it was being implemented in the backend. I didn't really try to figure it out as well by talking to them, but this was absolute failure on their part to do this. So increases probability of a correct guess with every new CAPTCHA added. Basically, when you try to brute force these websites, if you say do 1,000 failed requests, and your possibility of getting a good CAPTCHA or successful CAPTCHA really increases by 1,000 times with after your 1,000 and then your 2,000, then 3,000. If all these solutions get accumulated, well, I mean, the probability of a successful guessing is very high. Then you have persistent CAPTCHAs. Some websites did not want to create too many CAPTCHAs, so they would return the same CAPTCHA again and again and again until you solve it. Again, they can be brute force. So this is one very interesting finding which I had. It is called in-session CAPTCHA brute force. We'll see why we call it so. The similar pattern, you send the request to the session ID. If you do not get a session ID, create a random new session ID along with the random CAPTCHA. Now, you're setting the CAPTCHA solution in the HTTP session, so doing it right. And then you return the CAPTCHA with a new session ID if required at this point. The user submits the form with the session ID and the solution for the CAPTCHA that you set back on step 4. In step 6, the CAPTCHA is verified, and then the normal verification process happens. So this was the most interesting attack vector this and the next one which I'm going to discuss were the most interesting ones. Why? The CAPTCHA refresh or the new CAPTCHA getting into the HTTP session happens only when the request goes to register.php page. I'm just using register.php as an example, or the register page. This was the only page that was allowed to insert new CAPTCHA. So the fault, I can send multiple requests and I do not want to follow this redirect which says go to the register page, right? Normally your field or the CAPTCHA solution is incorrect. You go to the register page. I do not do that. I just stop there and I start submitting multiple requests. So when I'm disallowing this, I basically have the same CAPTCHA in the session till the time my request I allow to go to the redirect page. Any questions so far on this?
Not clear.
Not clear, right? So that's what I'm trying to understand. Is it clear that the CAPTCHA solution was stored in HTTP session here?
Yes.
Okay. And if anybody remembers the first slide we discussed, the session is normally generated at the register page, normally, or with the CAPTCHA page, right? So when this redirect happens at the step 8, they normally go to the register page, or they try. There is one more request coming for a request of a new CAPTCHA, and that is the time when session gets updated, right? Okay, let me come here. So here got stored into the session, and it will be renewed only when a new request comes there, right? This value will be renewed only when a new request comes for a new CAPTCHA.
Okay.
But if I do not allow, so I'm using a scripting engine. I'm not using a browser which will automatically follow the request or follow the redirects. So when I do that, I'm basically keeping the same CAPTCHA in the session.
I'm sending the solutions with the CAPTCHA again and again. I mean,
No, what I'm saying is this thing at step 3, right?
yeah.
I do not allow the server, or sorry, the client to do this again. Right? I write my own custom client and do not allow it to follow any redirects. So I submit one solution. I check what the response is. Is it taking me to success, or is it saying that I have to go to the redirect page, which is the register page? So the moment browser goes to the register page, it asks for a new CAPTCHA.
Okay.
And that CAPTCHA gets into the session.
So you don't allow that?
I just do not allow that to
You
happen.
only get the success and failure, and based on that you're predicting whether your solution was
That's correct. And I do not follow the redirects. So basically I have one solution in the HTTP
Only
session.
when you allow yourself to redirect, only then the CAPTCHA session will
Right. So, and based on that, I can brute force a CAPTCHA solution by sending like 5,000 requests, 10,000 requests.
whichever gets the success.
Yeah. So then I can stop there. But once I do that, probably this was the missing step here. So they are not clearing CAPTCHA state or session. You would be surprised to see the number of websites that are vulnerable to this. Amazing number. I mean, if you just try, if you get any website that implements CAPTCHAs, nobody clears CAPTCHA state when there is a failure. They just give all the responsibility to the page which is generating the CAPTCHA and storing in the HTTP session. So do test for this whenever you get time on any website that allows for CAPTCHA.
So it means that if you get a solution, you can create multiple registrations at once.
That's correct. That's CAPTCHA rewriting. So basically, here it was brute force. You try to get values. You are not interested to solve any CAPTCHA by yourself. You just allow your script to run, find one solution, and then you do the same again, but then you have one solution with you at that point of time, and then you write on that again. You send that again. You never allow it to complete. You don't even allow success to complete. You just keep on sending the request, and the
CAPTCHA solution.
same CAPTCHA solution would be used n number of times. So you rewrite on the same solution basically. You do it, you solve it manually, you solve it via any other means, but you can reuse it like n number of times. So
They have the session ID with the CAPTCHA associated, right?
yeah, that's what I'm saying. They have the session ID associated, but I'm not allowing the CAPTCHA solution to be changed.
You don't have to brute force, right? You can use
Yeah, I'm saying the brute force was one thing you may want to do, because if you're just not interested to solve anything by yourself, you don't want to invest any effort in that. Because once you have a successful CAPTCHA solution, you can send any number of requests, because the session will continue to have the same solution as long as this particular request does not refresh that or change that. Any questions on this? Because this will be very important when you test, and this should be tested. Every CAPTCHA implementation should be tested for
I'm
that.
not clear. Let's say it is the CAPTCHA says ABCD,
Okay,
and you send ABCD.
okay,
You got success.
Right.
After that, what else can you do?
No, that's it. He's not allowing to go
So-
success only. He's just coding it
No,
in the
but
same
he needs
state.
to. He will know that success came. He won't redirect to it.
Exactly. Since he's not using browser actually,
Yeah,
he's
yeah.
just, if I've understood it correctly, you're
Right.
just sending the request again and again.
Right.
You're not making the server to understand that, okay, you move to the next page and the session or change the session and just.
No, my question is,
Something.
after you know that ABCD was correct,
mhm.
then this attack is of no use. You have to refresh the thing.
No. So that's what I'm saying. Even if you solve correct or incorrect,
Right.
the session is not refreshed. The CAPTCHA solution in this session is not refreshed unless this page is called.
But then, how would I test a different CAPTCHA? That's my
No,
question.
here the main, if
I'm not able to understand your point.
Let's say there is a CAPTCHA called ABCD,
Okay.
which I want to figure out what is this image,
Okay.
right? So you start brute forcing ABCD
Right.
like that, and you get the thing that it's success.
Right.
But now I want to try a different CAPTCHA.
Okay.
So like let's say BCDE,
Uh-huh.
but that is not there on the server.
But see, that's what I'm saying. So you are not supposed to have any control of the CAPTCHA that you get. The server has to reissue a new one, right? We are not supposed to have any control. So if a client can control the CAPTCHA that he is testing it out, possibly, then there is no point of having the CAPTCHA, right? We had that CAPTCHA session identifier fixation.
Right.
So in that case, I know this is the identifier and this is a solution for that. So, really doesn't make any sense because I know I can influence that identifier, I can force that identifier into the HTTP session, and once I do that, I really know the solution and I can do that every time I want to brute force against a website. So with one identifier and solution, I can maybe create 1,000 email accounts. Right?
here his intention is not to use the guess the CAPTCHA. His intention is to bombard the server to create a lot of users actually. So you get a single solution, you're just posting it again and again, creating a lot of users and not allowing the server to come back to his state.
Let me give an analogy to this. Did
that
you guys
was-
see the hacks which said that, well, this hard disk encryption product does not clear passwords in the memory? A lot of these things are seen these days, right? SSH is not clearing the password in memory, or after it authenticates, it keeps the password in the memory for comparison. You can relate to that because here it is HTTP session which is holding the CAPTCHA solution. So you just don't clear that at all. Until the time either the session self-destructs after 20 minutes of your time if you set it, or till the time your machine is not switched off if you are not invalidating sessions.
So using that session to continue registering the
Yeah, so this is rewriting it. That is what it is. You have one session, one CAPTCHA solution. You just keep on
You
sending
just don't
them.
allow it to redirect.
Yeah, we just don't allow it to, not redirect, I would say. We won't allow it to
Clear the
clear the CAPTCHA state or refresh it to the new value. So that is what is important to understand. Any doubts on this? Okay. This is OCR assisted CAPTCHA brute force. So different OCR engines behave in different way. I tried with around 3 or 4 engines, and I zeroed in on Tesseract, which is the open source CAPTCHA engine. OCR engine by HP. So they open sourced it, and now it's being maintained by Google. It's available on Google Code. Just search for Tesseract OCR, you'll get to that page. It's a very good OCR engine, and I highly recommend it if you want to write your own CAPTCHA solvers. So OCRs are basically used to extract text out of images, and OCR assisted CAPTCHA brute forces, you get a CAPTCHA, you pass it through multiple OCRs. Each one of them may return a different result, sometimes not at all same, sometimes similar. And if you know that A is correct and B is incorrect, or both are incorrect, and they are different at these two characters, possibly you can try to combine them and get the correct solution. This again would require those vulnerabilities to be done on the live systems. If it's vulnerable to in-session brute force, in-session CAPTCHA brute force, or rewriting attack, you can basically reduce your time, the brute force time, a lot by this. Basically, you're just trying 3 or 4 OCRs, combining the results, testing them out, and coming up with the final result. Then here it goes. Solve with a single OCR, and then you solve with single or multiple OCRs, then start enforcing characters one at a time. Or you combine results of multiple OCR engines. Then
what are these OCRs using machine learning, supervised machine learning?
pardon?
What are these OCRs using to analyze the image? Are they using machine learning?
Yes. So Tesseract comes with a default training data,
Okay.
so that it is straight around 40 fonts
Okay.
and different type of spacing and all.
Yeah.
So it comes with that default data, and that is what I have used for this
So you
analysis.
train your algorithm
Yeah.
and you give it more information.
That's correct. And then you can better refresh the session ID for a new CAPTCHA if the current one is not doable. Coming to the final part, maybe not the second last part of the presentation, attacking CAPTCHAs with TesserCap. So these are the victims of TesserCap, which could be easily solved using TesserCap and with good accuracy, with minimum 20 to 30%. And this is TesserCap, a new tool which I wrote a while back. And this is the front screen where you can see just stats and all, which solutions were successful and the statistics. And let's talk about TesserCap a bit. It retrieves CAPTCHAs from the target websites, passes the CAPTCHAs through 8-stage image pre-processing algorithm. This is something which is custom that I wrote. For all the CAPTCHAs. We'll work with this and understand how various stages work. And then we generate a pre-processed CAPTCHA. So you can see that how the noise has been completely removed from the CAPTCHA. And then you give it to Tesseract OCR engine, and then you get the final solution. Before you really look into the demos, there are 2 important image processing techniques. One important image processing technique that I would like to discuss is called spatial image enhancement. So what it does is, I'll just give you a gist of this. For example, there are 9 pixels in an image, right? What it would do is multiply all of them by 1. The value at each pixel, like for example, one pixel has a value of 10, other has 20, 30. So these are called neighbor. This is called neighboring relationship. And this image is from second digital image processing book by Gonzalez and Woods. Very good resource on image processing, and I use it extensively while writing TesserCap. So you multiply things, multiply all the pixel values, and then you divide them by 9, or the total coefficient sum. So 1, 2. So here we are assigning weights. So these values are called weights. So this is 1. In this mask, so this thing is called mask, and these are the values assigned, coefficients for each of the components there. And This is another mask. You can see that the number with which it is divided should be equal to sum of all the coefficients, so that the value stays between the permitted range of the pixel. So it's normally 0 to 255 and it should stay in that. So for that purpose, this is what we do, and the purpose of this is called softening filter, and this is the softening mask. You give it an image, it will distribute the noise or the energy of that image to surrounding pixels. So this will help us remove noise from the image. We'll see how in the next image that I took from his book again. Here you see the purpose of the experiment was to identify the large bodies out of this image. So what these guys did was passed it through 15 by 15 averaging mask. What we saw here was 3 by 3, and they created a bigger mask and blurred it all together, and then put a cutoff so that if the value is above x, it is shown as white here. I mean, x is a value at a pixel x. So it would be like 150. Let's say it's 150. Then if anything is above 150, that will be white. If anything is less than 150, it will be like blacked out completely. So that basically helps you identify the brighter bodies in this NASA image.
So you're relying on the fact that the engine that will generate the captcha will try to have the alphabets more prominent
That's
to the
correct.
user, and based on that you're trying to reduce it so that whatever below the threshold you just completely ignore it, and above that is a probable image. Is it?
That's correct. So we will see all of these in action when we look at TesorCAP. So let's move on to TesorCAP. So this is a Ruby Rails server that I have, and that hosts around 3,000 CAPTCHAs, and we'll be seeing few of them as we test today with TesorCAP. Once it's up and running, we'll see. So this is the home screen. Akash, just for information, the presentation started at 2:20. So I'll be taking some time beyond 3. So there's something wrong here. Yeah, this is much better. Right, so we'll just see some features of TesorCAP. I'm trying to solve 15 CAPTCHAs, and these are the easiest ones that I have on my stack. So let's see how well it does while solving these CAPTCHAs. The main purpose of writing TesorCAP was there was no tool available out there that would help you analyze and test CAPTCHAs efficiently. I mean, everybody just spent writing scripts using Python or whatnot, Python, Ruby and all, and the clients were never satisfied because they didn't have any tool which they can test against. So let's see this. This one is correct, looks to be correct. And then this one is correct. This one is correct. This is incorrect. This one is correct too. This one is again incorrect. This one is correct. This is incorrect. This one is correct. Can you please help me? I'm just a little slow
Right.
right now. Post
Wrong.
lunch. Let's go to the next page.
Yes.
Right. Right?
Yeah.
This
Wrong.
is incorrect, right?
Yeah.
So we'll mark them as correct, and then we move on to what is not correct. Mark is incorrect. So it becomes very easy to visualize where what stands. Something is correct, and then you can see the statistics. So it says correct percentage is 60, and then incorrect is 40%. So statistical analysis support, you can quickly run the tests, analyze, show to the clients that this is how it is, or to the developers.
But does it improve after, I mean, does it learn it on its own? Let's say on the fourth one, MSMNZIK, you
Okay.
said SI or whatever.
Yeah,
So you mark it as incorrect.
That's correct.
Does it learn that, okay, that was not I, that was not I, that was M in fact?
correct.
No,
So
it doesn't.
this is one of the fonts that I used, was not a part of maybe Tesseract's default training.
Okay. Acha.
So what I said was I used only Tesseract's default training
You
data.
haven't, you don't.
I haven't trained it, but
It
you can definitely train Tesseract or Tesseract. Yeah, you can definitely train Tesseract to solve their CAPTCHAs more efficiently. So once you're able to update its training database with your own CAPTCHA set, it will really work a lot better. I tried it out for some of things, but I really did not complete it. I did not get time to complete the entire training set for one particular type of font. I planned to have that for my presentation, but I just could not complete
How
that.
long does it take to train?
One day should be good enough. Yeah.
Or one font?
I mean, see, it depends. There is a learning curve.
Right.
So I'm just saying for the first font you train it, you might learn Tesseract, then you might create boxes, and you assign the values to every box, and then then finally, there are multiple files generated. You need to combine all of them, and then create a final database. So this is the version which I used for this is 3.0 of Tesseract. New versions might be coming, and they will be better and a reduced learning curve.
Tesseract does not have any GUI, right?
Pardon? But it's a command line based tool. Yeah. So that is called from this program, and the CAPTCHA solution is retrieved
And
from
is there any good documentation for Tesseract? I thought
Tesseract or
Tesseract.
Tesseract, yes. There is a very good Google code page. You can go there. Documentation is quite good. I mean, I like that, but I learned a lot from there. So it should be helpful for you as well. There are a few other options that Tesseract provides. As I said, I tried with multiple engines and zeroed in on Tesseract OCR. That's why you see this radio button. I had given 3 here. The other 2 I just removed as I kept on. I tested it more. So Tesseract only lives so far. If I find something better than Tesseract, that might come in. Then you have proxy settings. We do not have direct internet connection all the time, so you can provide a proxy settings and then access CAPTCHAs. Then this is character set. What this basically does is Tesseract can be given a configuration file at runtime, and that file you can provide the characters that your CAPTCHA has, and it helps improve the efficiency and accuracy of the detection. When you say it's only lowercase, it has to look for only 26 characters, right? And then if you say it's uppercase only or uppercase and numeric combined, it would look for only an uppercase and numeric. With lesser sample space, the detection is better. And I've seen this helping me a lot while doing my assessments. And then there are options to follow redirects. By default, Tesseract does not follow any redirects. So I allowed it to follow redirects for the scenario which we discussed. You go to a CAPTCHA page, it will return you some identifier which you have to follow. So for that. And this is image pre-processing. We will see how it works out. And this is CAPTCHA HTTP request header. Why this is here? Because a lot of times websites rely on session, and if you do not provide a session, they do not give you a CAPTCHA. Or they return different type of CAPTCHAs based on your user agent. If it's a mobile agent, it will give you a easier CAPTCHA. If it's a desktop agent, it will give a complex CAPTCHA, which is like heavier JavaScript and requires heavy lifting. Sometimes user agent is verified, sometimes session ID, sometimes combination of things, sometimes they expect a referrer header to be present. So all these things, I have seen them while I was working, and this really helps you provide your headers here and retrieve CAPTCHAs from the website. This is the image pre-processing module that I wrote down. There are around 8 stages, 1, 2, 3, whatnot. And I'll explain to you these things as we test more CAPTCHAs now. Let's see. So this is the CAPTCHA which we are seeing right now. As you can see, none of them was solvable by Tesseract because there is a lot of noise in the backend. It's not clear, and the noise is also very similar to, it's in digits, so it's not able to figure out what lies with the CAPTCHA, what is the text that it has to extract. So let's see how the image pre-processing can help us. You can right click on any CAPTCHA, send it to image pre-processor. Then if you look at this CAPTCHA carefully, you can see that the white color or the text color stands out completely from the rest of the stuff, right? That means that the distribution of the pixels towards the 255 value, which is the white, should be less because these are only the characters, and rest everything is towards the black side or the gray side, right? So let's try to run one filter. This is the one which I'm starting with because this makes more sense and will be easy to understand. This is a histogram that is generated for every CAPTCHA that Tesseract analyzes, and you choose to analyze that. So on the left, on the x-axis, you would see the value of the pixel or the RGB. I wouldn't say RGB, but grayscale value. So it can be 0 to the minimum to 255 at the maximum. You can see this slider here. I can set this slider to a value, and then based on that value, either the below the threshold it will be white or black as you choose it to be. So we'll see how this CAPTCHA here changes as we change this slider. Let's see this. What we are doing right now is, if it's about 25 or 21, which you can see here, everything has to be white. So number of pixels, the value against the number of occurrences of that particular pixel, right, of that particular value. So white appears to be less. So obviously to the right is white. So if I set a cutoff somewhere here, we can see that only the text which is white comes out completely. And then we can invert and solve it. Quite close? I believe it's taking O or 0. So let's try to run it again. But before that, we have to enable image pre-processing. So what this does is, it puts the image pre-processing filter in line with the CAPTCHA solution, and before it goes to Tesseract. So I did that, right? Earlier we didn't have any solutions. So let's start this again. Much better. So yeah, it's faulting at zeros and O's, but otherwise it's doing quite good. Let's go to something which is a bit more involved. I'm going to disable this first. So a lot more noise than the previous one. Let's send it to image preprocessor again. So this is a grayscaling filter which I created. The reason for this, the existence of this is, I wanted to ensure that all the CAPTCHAs that go to Tesseract go in two colors. It should be white or black, and there should not be any third color, and that really helps us here. So the purpose of grayscaling is to basically use one of the averaging algorithm to increase or to make the text more visible than the surrounding noise. So for this text, this CAPTCHA, I saw it was minimum minimum was doing the best. So you see, when I do a minimum, it chooses, so the CAPTCHA which came from was color, and when I do a minimum, I choose for any pixel, there are three components, red, green and blue. I choose a minimum out of that and replace that for the value here. And then I would just try to do a, you can see text is starting to emerge a bit. I have already solved these, so it might be easy for me to let's see how it goes. 60. May not solve it. For 2 it's saying D, 2D PVX, yeah. So that's one character that's missing. We will again enable image pre-processing, say bump up the count to 10, and then we'll start. So we can see that 1, then 2, 3. Maybe this may be incorrect, but I'm not very sure. So out of 10, we are able to solve around 3 just by having that image pre-processing in place. So
I just have one question.
yeah.
Initially we did image pre-processing manually, right?
Yes, we did it this time as well.
What is the checkbox that you do?
Yeah, I'm just doing. So checkbox is, so these 8 filters, right? Out of these, 3 are mandatory. Everything has to pass through these filters. After this, you can either put them in line or you put them out of line, right? So when I check this, it says activate that, and it will start it will bring that filter into picture. So it will be a part of the pipeline with which the CAPTCHA is going through. So here, if I say the chopping filter, what this does is basically, if you have a line, right, normally developers insert random lines in CAPTCHA. So that lines are not generally same width as the text. So if there is, so what this does is, if you have a line which is like say less than 5 pixels or any continuous color scheme which is less than 5 pixels or 2 pixels, as I chose in the settings here, it will be completely removed with the value that you choose. It can be black or white. So that is what it does. Few things are basic image processing techniques and some are sheer hacks based on the observations I had on like plus for 200 CAPTCHAs that I worked on. So here I'm able to remove most of the text, most of the noise just by chopping off whatever is extra here and getting the CAPTCHA solutions.
I didn't get one thing. I mean, this time we did image processing by manually, right?
Right.
And next time from the options we selected the image processing.
Right.
And then we started the.
Okay. Let me put that in right perspective. When CAPTCHA, as a CAP is launched on a CAPTCHA, right? It does not pass every three. By default, it does not do image processing on it. So basically, you have to send your CAPTCHA here for analysis, create a filter which you can create a complete set which you think is good enough. Then you allow your CAPTCHAs to pass through this.
So that is sort of a training for it.
Yeah, training for this. So basically, you train it to clean the noise. That's what it is.
Okay.
So the noise goes off.
It's correct.
Yeah. So basically, you solve it here, then you check it here that how is it able to solve it? So you test the solution here with this button at the end. I'm not sure everybody is at the end to see able to see this. So you check the solution. You can do multiple iterations right here without downloading thousands of CAPTCHAs. Do this and then put it in line, and then all these filters which you select here would be retained for every CAPTCHA that you get down from the server. And then let's see one or two more maybe. This one is one. So this is again one CAPTCHA provider. It's CAPTCHAs.net. That is the website. They are CAPTCHA providers. The previous one was OpenCAPTCHAs.net. So these guys basically provide CAPTCHA solutions to be implemented on third-party websites. So they are like just like eCAPTCHA. I can use their CAPTCHA, have it on my application or my website, and then they claim that they can protect that. But in reality, that doesn't happen. So this is one more, and I'll just try to run through it. I'll just do an average here. So this is the control I was talking about, the smoothing and sharpening. So it has 6 canned filters that you can apply to any CAPTCHA. So 6 is, one is smooth, second one is also smooth with different coefficients. You can write your own smoothing masks, you can enter values, you can save the mask, and that will be applied to the CAPTCHA and the test. So you can basically add 3x3 masks for every pixel. This will be applied and the noise will be distributed. I will be able to show you one interesting example. Let's see this. When you see this histogram, for value of 0, which is black, there are around 6,000 pixels. For 255, that is white, there are 12,000 pixels. And in between, there is something on 150 value. So it is pretty neatly laid out, right? If I put this mask in between, what it would do is, it would spread the noise. You can see the new histogram. So, and all these stages would refresh immediately after you select anything which is previous. So if I make any change here, that will be reflected everywhere. So you just need to change once and you can see the effect. You don't need to do everything again and again. Just go with the smoothing filter one. So the sharpening masks are these, which will help you edge detect things. I really haven't been successful solving CAPTCHAs with these masks. So for future release of this this tool, you may not see this, but and this is for experimental purpose right now. But you might use 1 and 2 along. So I'll get back to 1. Give it 2 passes. Get back. Text is getting clear. This should be good. So we don't need chopping here because anyway it's like, but we might need to modify the border because border width is sometimes plays a very critical role. What happens is when there is a OCR engine, it starts analyzing the text area. If it sees border is all black, it understands that the black is the base color. And what happens is when your text is also in black, it would not recognize it at all. So there is one filter here which would basically chop off your border with white or black color, whatever you want, would repaint that area for you. And then you can just try to solve it. Okay, so let's see, I'll try to do only lowercase here. Let's see how it goes. Yeah, ZF, it's still better than what we had earlier, right? That is what I said, if you select the right character set, you get a different result. If you don't, you get a different result. So here it's lowercase only. We'll enable MHP processing, solve 10 CAPTCHAs, and let's see how it goes. Ready, go? 20%, 20 to 30%. 1, 2,
Yes.
3, 4. Maybe not. Maybe yes. But yeah. Around 3 or 4. So 30% is considered to be a very good if you are solving CAPTCHAs. If you do this on reCAPTCHA, I mean you would be at DEFCON doing some really cool stuff. Right. So this is one, and last one feature I would like to talk about this is there is something called as CAPTCHA buckets, which I have implemented to ensure fine-grained control of CAPTCHA values, what you allow to pass as a black, what you want to allow as a white, and what you just want to leave as it is. So let's try one of those CAPTCHAs which I have, and that will be the last thing probably before you wind up for the day. For 10 more minutes. Now. Yeah, I was talking about the border color, right? I'll just show the demo quickly. I'll send it to MHP processor. Border is already, I don't need anything else. I just try to solve it. It will say fail. I mean, for those who are sitting in front can see that. And if I just say remove the border, you might see a solution which is very close and getting better. So this is another CAPTCHA which is like a lot of noise everywhere. Won't be able to solve because of the random noise coming here and there. So let's try someone. Can someone please choose which one we want to solve here?
This PMR.
SR? Which one? Which column please? This one? Yeah, let's try this out. All right. So my first job is to make sure that the colors, the white, the black, and the text, they are all separate. So I'll try to use this and how it goes. So I can see that when I use the minimum, the lines go black and the text is still visible. It can be like taken out of that. So let's try to use the buckets now. So what these buckets do is, if you have some pixel value which is between 0 to 12, it will put it in bucket 0. 30 to 25 goes in bucket 1. 26 to 38 goes in bucket 3. So it basically bucketizes the entire, it's a histogram but it's coarse, a little coarse than the other one, but provides much more control. You can select every bucket and choose it to be either black, white, or if you want to leave it as it is. So let's try it here. Yeah, so let's try it here. Yeah, that goes off, right? The lines are off. So I can just play around and see how it goes in the other thing.
Is this something you came up with, or this is like a standard thing?
No, this is like something I thought of. So everything you see in MHP processing is based on my observations, like all the CAPTCHAs that I analyzed. If I select this as black, you can see U is coming out now. White. Yeah, this is going to be black now. Give better text. Yeah, that takes a lot of noise. This is black. I think Rest everything can be white easily. And that will take off all the noise that we have here. Okay. So probably more work to do. Well, it's in lowercase right now, so I'm going to make it uppercase and numerics. Let's see how it does. Yeah, SVTU, very close. Not the complete solution, but yeah, very close. We can try other ones here. For this, it works around 20. For this CAPTCHA, the success rate is around 20%. So if I create a good map, spend some time on it, it works well. Let's try to just pass it through standard. Yeah, so see, PSWM, 5 LDP, one is solved, this one is correct, and then T3A4, this is correct, this is okay, yeah, so 3, that's 30%, that's quite good, I believe, with the type of CAPTCHA it is. So that was about TesorCap. This is how I ran it on various websites. CAPTCHAs.net, the accuracy was 40 to 50%. With default Tesseract training data plus one, it was not reCAPTCHA analyzed, it was one training data provided to TesorCap in the image processing. So that is how the success accuracy is here. CAPTCHAs.net, you can see some websites. reCAPTCHA, I couldn't touch. Web spam product, yes. PHP CAPTCHA, again 10 to 20%. So these are the big websites. Wikipedia could be solved around 20 to 30%. eBay, anybody works for eBay here? Reddit, CNBC, these are websites along with the podcast track. And CCNN is like 80%. Food Network is some website which is 160 ranked in podcast. So that's very nice. Also we call it as conclusion. We try to be good at the end. So this should be the secure CAPTCHA implementation. All the steps along with clearing the CAPTCHA state on the session side. So basically you have a CAPTCHA, you generate new random CAPTCHA here, set it in STP session, then while verification you clear it and then do a proper redirect. Important points, the client should have no influence or knowledge about the CAPTCHA content. It should be a random CAPTCHA with a large sample space with alphanumeric, maybe special characters, but that's not really recommended. Alphanumeric on a minimum, which should be case sensitive. Then the CAPTCHA should be high to perform image, high on complexity to perform image pre-processing, segmentation, classification. Then a client should not have direct access to CAPTCHA solution, like we provide in hidden fields, don't do that. And CAPTCHA should not be reused. Questions, please?
Why were you not going to ask anything on reCAPTCHA?
So reCAPTCHA, the thing is,
because
this tool
itself requires 30% success.
yeah, that's what it is. But reCAPTCHA, what happens is, this tool basically out of 3 things which I talked about: image pre-processing, classification, and segmentation. It does 2. It does image pre-processing and it does classification. Tesseract, OCR engine does the classification for me, and in the pre-processing part I do myself. But I haven't implemented any algorithm to segment CAPTCHA. So in reCAPTCHA you have text that is co-joined. So there is no good algorithm right now available which can break the type of join or the algorithm, that algorithm in particular. So that is the reason reCAPTCHA is not breakable. And in these days you can see that using TesorCap, I was able to solve half of reCAPTCHA. So half of their CAPTCHA is a book, text, a word from a book. The second half is their own implementation. So the first half, this can always solve 100% of the time, but the second half it can never solve. So that's why I said reCAPTCHA to be 0% because the entire solution is what matters.
What about solving the reCAPTCHA to the audio capture? Because what I realized is that the audio capture is very simple, because what the thing is that the person who will be going for the audio capture is a handicap kind of person, so the sound is very easy to break down.
That was that is what I'm working on right now, so probably you will see more details in the future. And you have a detailed white paper on TesorCap available. It's around 25 pages. You can see every functionality, how it works, why it works that way, and you can understand every single image processing stage, why it should be used, how it should be used, and it's around 25 pages in length, so would be a read if you're interested.
I just use this tool a while back, and whenever I click on that solve button, that is the image processing. Whenever I click on, there is a runtime error occurring in that.
Which? Okay.
The last image processing. Whenever I click on solve captcha finally, there's some sort of a runtime error. It gives you the path. It creates that image into the background.
Right.
But here we didn't have any option to create an image, right? But in the background we might be creating some sort of image.
Yes, I know that.
Like after, before just clicking on solve.
Right.
It just gives you a pass of that PNG image, and then I have to go separately on that PNG image, and then I need to upload it to filelcon or select separately.
Okay. Maybe I can look that if you can provide me the configuration. I would definitely look into that. Thank you guys.